We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live.
3I/Atlas, the long-period interstellar comet first spotted racing through the solar system, had fascinated scientists and skywatchers since its detection. Its unusual path, its vast size, and its sheer otherworldly nature all made it stand apart from more ordinary visitors to the inner solar system. For months, telescopes tracked its luminous arc against the darkness of space, a reminder that our solar neighborhood is not isolated but connected to a broader galactic arena. When it sent out what is now considered its final measurable signal, the moment was met with both awe and unease. That signal carried not just data about its trajectory and material composition, but also a dramatic conclusion to its brief encounter with our sun's domain. It was as if the universe itself had offered one last flare, a final cosmic message, before the object slipped back into interstellar darkness. Before we start, smash the like and subscribe buttons for more updates. The final signal of 3I/Atlas was more than a burst of energy on a screen. It was the culmination of careful listening by some of the world's most sensitive instruments. Arrays across continents were calibrated to capture every fragment of information the comet transmitted through its interaction with solar wind and cosmic radiation. The last recording showed a pattern that immediately triggered discussions among researchers. Its intensity, the sudden fluctuations in brightness, and the resonant frequencies it released were unlike any other cometary behavior observed. Scientists compared the data with previous interstellar objects like 1I/Oumuamua and 2I/Borisov, but Atlas's closing performance stood alone. Its light seemed to dim, then surge with a structured rhythm that hinted at processes deeper than simple outgassing or fragmentation. To many, this was not just a natural finale, it was a message written in the language of astrophysics. The implications of such a signal were profound. First, it reinforced the fact that interstellar objects are not rare flukes, but a steady reminder that the void beyond our planetary system is active and filled with wanderers. Each visitor, brief though it may be, carries with it the story of another star system, another chapter of cosmic history. The final act of Atlas suggested that these stories may not be as simple as ice and dust carried along random paths. The structured pulse, if interpreted correctly, could hint at underlying patterns of material instability shaped over millions of years in alien stellar nurseries. If so, Atlas had provided humanity with a fragmentary but invaluable clue to the environments where it was born. For planetary defense specialists, the final signal also sounded like a call to vigilance. Objects like Atlas may not collide with Earth in this case, but their trajectories demonstrate just how thin the margins can be. A few degrees of difference in orbital inclination, a slight variation in timing, and such a body could cross paths with our planet. The energy released by an impact of an interstellar comet of Atlas's size would dwarf historic events like Tunguska or Chelyabinsk. The data encoded in that last flare underscored the unpredictability of these encounters and emphasized the need for early warning systems capable of detecting such bodies years, even decades before they approach. It was less about the fear of imminent disaster and more about a sober recognition that the cosmos still has the power to surprise us. The cultural impact of the final signal was no less significant. Humanity has always turned its gaze upward, weaving myths and meanings into celestial events. When Atlas's farewell was announced, social media lit up with interpretations ranging from scientific wonder to apocalyptic speculation. For some, it was a reminder of how fragile our place is in the universe, how brief even civilizations might be compared to the journeys of interstellar travelers. For others, it was a poetic sign, as if the heavens had sent a flare to remind humanity of its responsibility toward the planet it calls home. Artists, writers, and thinkers seized upon the imagery, seeing in Atlas's last gesture a metaphor for endings, transformations, and the fleeting beauty of existence. Astronomically, the event also raised questions about whether interstellar bodies may carry more than physical material. Could these signals, interpreted purely as natural processes by instruments, also encode subtle information about the environments they have passed through? Cosmic rays, solar radiation, and gravitational interactions all leave their imprint on an object's surface and trajectory. In that sense, Atlas's final broadcast might be seen as a compressed archive of galactic history. Decoding that archive may one day allow scientists to reconstruct the neighborhoods of distant stars without ever leaving our own. If even a fragment of that potential is realized, then Atlas will have changed our understanding of astronomy forever. The structured quality of the last signal left some researchers pondering whether natural processes alone could account for it. Comets typically fragment or sublimate in unpredictable ways, producing light curves that are chaotic rather than ordered. Yet Atlas displayed a rhythmic sequence before fading. It is possible that resonances within its fractured body produced this pattern, much like vibrations in a collapsing structure. Another possibility is that the complex interplay of volatile ices, metals, and dust created periodic releases of energy as the comet neared the threshold of instability. These interpretations remain speculative, but they underscore the need to study interstellar objects in detail before they fade from view. Each one is unique, and Atlas's final behavior was a vivid demonstration of just how much we still do not know. The international collaboration surrounding the event was another striking element. Observatories from Hawaii to Chile, from Europe to Asia, coordinated to track Atlas in its final hours of visibility. Space-based telescopes tuned in as well, offering perspectives from beyond Earth's atmosphere. The combined data painted a fuller picture than any single observatory could have provided. This spirit of cooperation mirrored earlier endeavors like the detection of gravitational waves, where humanity's best instruments are combined in pursuit of answers larger than any one nation. Atlas's final act thus not only expanded scientific horizons, but also demonstrated the unity of purpose possible when humanity faces the mysteries of the cosmos together. The implications extend into the philosophy of exploration. For centuries, humans have regarded comets with a mixture of fear and fascination. They were omens in the sky, unpredictable and untamed. Modern science has stripped away much of the superstition, replacing it with data and orbital mechanics. Yet Atlas reminded the world that even in the age of advanced technology, the cosmos retains its ability to astonish and unsettle. Its final signal was not an omen in the old sense, but it carried with it the same awe that once inspired ancient observers to record comets on stone tablets. The difference today is that we can interpret the physics behind the spectacle, but the emotional response remains much the same. Technologically, the lessons learned from Atlas are already being discussed in terms of future missions. There is growing momentum to design probes capable of intercepting interstellar visitors. If a spacecraft could be launched quickly enough, it might study an object like Atlas up close, sampling its material before it disintegrates or escapes. The final signal of Atlas, rich with unanswered questions, has strengthened the argument for such rapid response missions. They would require new propulsion systems, agile planning, and global cooperation, but the reward would be unprecedented access to material formed around distant stars. Such endeavors would place humanity at the forefront of interstellar exploration without even leaving the solar system. From a purely observational standpoint, Atlas's finale underscored the limitations of current instruments. While the signal was detected, much of its nuance remains shrouded in uncertainty due to gaps in coverage and the inherent difficulty of studying fast-moving, dimming objects. This has reinvigorated discussions about the need for more powerful telescopes, particularly those capable of scanning wide fields of the sky continuously. The more interstellar objects we can detect early, the better our chances of studying them before they vanish. Atlas may have been only the third such body conclusively identified, but its departure has opened the door to countless others yet to be seen. The event also prompted reflections on time itself. To think of Atlas's journey is to confront scales of distance and duration far beyond human experience. It likely traveled for millions of years through interstellar space, carrying with it frozen records of ancient environments. Its brief intersection with Earth's skies was a fraction of that journey, yet for humanity it became a monumental moment. The signal it emitted, though lasting only moments, connected human observers to epochs of galactic history. It was a reminder that while human civilizations measure time in decades or centuries, the cosmos unfolds on scales of eons, and every passing visitor is a messenger from those vast stretches. In terms of human imagination, the finale of Atlas has expanded horizons as well. Questions about life beyond Earth often dominate discussions of the cosmos, and though Atlas offered no direct evidence of biology, its interstellar origin reinforced the interconnectedness of galactic systems. The materials it carried, carbon compounds, water ice, metallic elements, are the same ingredients from which life as we know it arises. Its signal, in essence, was a confirmation that the raw materials of life are scattered across the galaxy, moving freely between stars. This realization fuels both scientific inquiry and philosophical wonder. If the building blocks are everywhere, then perhaps life itself is not confined to Earth. Even as Atlas faded into the distance, its legacy endures in the questions it leaves behind. Was the final signal simply a natural byproduct of its disintegration, or does it encode deeper information about its origins? How many more such objects are traversing the solar system unnoticed? What role might they play in seeding planetary systems with material from distant stars? These are not questions with immediate answers, but they are the kind of questions that drive science forward. Atlas may be gone, but its last act ensures that the study of interstellar visitors will remain a vibrant field for decades to come. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I/Atlas's final signal? Warning or overhyped cosmic event? We want to hear from you. Thank you for watching and see you next time.